Another important rule that exists there in the theory of probability is multiplicative rule. But before I move to it, I would like to discuss a couple of extra things. First of all, there is something called conditional probability, and this is the probability that event A occurs given that event B occurs or has already occurred. And this is how this conditional probability is denoted. So once again, the probability that event A takes place given that event B has taken place. And to calculate this probability, we need to take the intersection of event A and B, so the probability of these two events happening at the same time, and divide it by the probability of event B. So let's have a look at an example. So to develop programs for business travelers staying at convention hotels, Hyatt Hotels Corporation commissioned a study of executives who play golf. The study revealed that 55% of the executives admitted that they had cheated at golf. Also, 20% of the executives admitted that they had cheated at golf and had lied in business. Given that an executive had cheated at golf, what is the probability that the executive also had lied in business? To solve this problem, we need to define some events. So, event A is executive had lied in business, and from this description, we don't know the probability of this event, so we leave it without any probability. Event B is executive had cheated at golf, and we know the probability of this event. Here it is. The study revealed that 55% of the executive admitted that they had cheated at golf. So the probability of an executive cheating at golf is 55% or 0.55. And we also know the probability of the intersection of event A and B. So the probability that executive had both lied in business and cheated at golf. And we know this from this sentence. Also 20% of the executive admitted that they had cheated at golf and had lied in business. So the probability of these two events happen at the same time is 20% or 0.2. So to calculate the probability that the executive had lied in business, given that this person had cheated at golf, we need to do the following. So we take the intersection of two events and we divide it by the probability of an executive cheating at golf. So 0.2 divided by 0.55, we get the probability of 0.364 or 36.4%. So the probability that an executive had cheated at golf given that this person had lied in business is 36%. There are also independent events in the theory of probability, and we say that the events are independent when the occurrence of one of these events does not change the probability of event A. So in a sense, if B happens, it will have no effect on event A, and vice versa. If event A happens, it will have no effect on the probability of event B. So whenever we try to calculate the conditional probability for these two events, we will get that in case of probability of A given that B has happened, it will be just equal to the probability of A, and vice versa, the probability of event B given that A event has happened will be just equal to the probability of event B. And if the events are independent, we can use this formula to calculate the probability of intersection of them too. So we've already seen this formula when we discussed compound events, the intersection of two events. So as you can see, that formula that I've already discussed only works in case of independent events. So the probability that event A and B happen at the same time is just the product of the two individual probabilities. However, it might happen that probabilities or events, will not be independent but actually dependent. And in this case, we need to apply the general multiplicative rule of probability. So if you would like to find the probability of intersection of event A and B, given that those events are dependent, here is the formula. So we take the individual probability of event A and we multiplied by the conditional probability of event B given that event A has happened. Or equivalently, we can get the probability of intersection of event A and B by multiplying the individual probability of event B by the conditional probability of event A given that event B has happened. So let's see how this can be applied to some example. So for example, what is the probability of drawing hearts on 2 consecutive draws? The deck has 13 hearts out of its 52 cards. So let's define event A. So event A is that the first card is a heart. We know that there are 13 hearts out of 52. So the probability of drawing a heart is 13 divided by 52. And now we need the conditional probability that the second card is also a heart, given that the first card is a heart. So to calculate this probability, we need to keep in mind that one heart is already out. So we have 12 hearts out of 13 hearts, and we divide it by 51 because one card is already out. So we have 51 cards out of 52. So the probability that we draw the second heart, given that the first card is also a heart, is 12 divided by 51. So to calculate the intersection of event A and B, so the probability that both cards are hearts, we need to take the probability that the first card is a heart and multiply it by the conditional probability that the second card is a heart, given that the first card is already a heart. So we take 13 over 52 and we multiply it by 12 over 51. And we get that the probability of this intersection of events is 0.0588 or 5.88%.